We are going to discuss Felkin Anh model. In diastereomeric synthesis, there are three models that are familiar. One is Bullock's model, another one is Cram's model, and the widely accepted model is Felkin Anh model. So in this model we will be discussing two reactive conformations. One is more preferred conformation, another one is less preferred conformation. We have to consider a carbonyl compound to which the large group of the alpha carbon usually will be a right angle to each other. Let us look at the model. We know how to represent the Newman projection. There will be a front carbon that will be represented as a dot that is towards you, and a rear carbon that we will be writing as a circle. So to the front carbon we will be attaching the carbonyl group. It is attached to our group. As we saw in the Bullock's model or Cram's model, there are three groups in the rear carbon. One is large, another one is small, another one is medium. So we have to write those three groups: M, L and S. S represents smaller group, M represents medium sized group, and L represents large group. So here you can able to see the interaction between the R and S. It's a gauche interaction. It is the interaction between R and S. So a smaller group is interacting with R is preferred. If medium group or large group, if it interacts with R, that will not be preferred conformation. So here you can say it is preferred. It is preferred as non-bonded. Interactions are less. Interactions are less. Interactions are less. Let us consider a R prime minus is attacking the carbonyl carbon. Attacking the carbonyl carbon. It leads to, once the attack occurs, then OH goes towards that side. Actually O minus will form, it abstracts a proton. We have to assume like that, and OH will be forming, and R prime and R will be there. As such you can write S, L and M. Now we have to, this structure is more like an eclipse structure that will be unstable, so we have to write staggered conformation. R prime, OH, R. The front carbon, this is front carbon. Now the medium sized group, L group and S group. This will be the major product because the interaction is between R and a small group. Less energy interaction. So this will be the major product that we can able to predict. So what we are discussing in this model, there will be two reactive conformation. This is one of the reactive conformation that were considered. In both the conformation you could see L will be right angle to the carbonyl group. Carbonyl double bond, you can say carbonyl double bond. There is a double bond, this L group is a right angle to that particular carbonyl double bond. So Another conformation I will be writing that you will be understanding, it will be unstable automatically, because there the interaction is between R and medium sized group. Let's look into that also. I will be writing without fully rubbing the structure, just altering the groups only. Large group will be here and medium group will be here and small group will be here. So here the interaction is between medium group and R group, and R prime minus is attacking the carbonyl carbon. So this one is less preferred, as non-bonded interactions are more. So after the attack, we will be getting, since the attack occurs at this particular point, OH will go towards that particular side. R. Now we have here the small group, here the large group, and here the medium group. It is more like an eclipse structure, so we have to write the correct conformation. We have to rotate now. So OH, R prime, R, L, S, and M. This will be minor. Why? Because the interaction between M and R you can able to look at, so it is a less preferred conformation. So the product that is going to form through this particular conformation will be minor. So between the two possible conformation, one with the small group gauche R is usually preferred. That is what we have to look at now. Why? Because the non-bonding interaction between R and S will be lesser. It will be minimized. Whereas R and M is larger. So out of two conformation, the interaction with R and S, as we discussed earlier, will be preferred one. So the major product is formed by the nucleophilic attack on the carbonyl from the side anti to R, L, the large group. You'll see here even the minor product that we are writing, but R is approaching opposite to L. L is located in the region that is opposite to the approaching nucleophile. So this particular model, whatever Felkin Anh model that we are discussing, it exactly predicts the stereochemistry similar to Cram's model. Let us consider an example. Reaction between alpha-phenyl propionaldehyde and methyl magnesium bromide and MgBr, methyl magnesium bromide. Let us represent this alpha-phenyl propanaldehyde with smaller the group that are there in alpha-phenyl propanaldehyde can be represented as a smaller group, larger group, and medium-sized group. Let us consider S equal to hydrogen, M is equal to Me, and L is equal to pH. We are discussing the groups that are represented in alpha-phenyl propanaldehyde as S equal to hydrogen, M equal to Me, and L equal to pH. So the structure can be represented as a double bond O, the large group that we know already, it will be represented as pH. The preferred conformation that we are talking about, where the interaction between here hydrogen is attached to the carbonyl carbon, Me and hydrogen. This is actually the medium group, this is smaller group, and this is larger group. Now Me minus from Me MgBr is approaching. Then we will have the structure after the attack. Me, OH, pH will be there, Me will be there, and hydrogen. Here the interaction is between hydrogen and hydrogen only. That is preferred conformation. Preferred. Now we have to write the structure. This is in eclipse form, almost you can say. So we have to rotate the structure in such a fashion that we will be arriving at Newman staggered. So we have to rotate the structure. I'm sorry. Me, OH, hydrogen, and here we have to write as such Me, pH, and hydrogen. So this Newman structure, while converting to Sahas followed by Fischer, leads to this is Sahas eclipsed, Sahas staggered, sorry. You write to Sahas eclipsed. So this is erythro, major product. Major. So similar to Cram's model. In Cram's model also we will be getting erythro as a major product. In this case also, in Felkin Anh model also we are getting erythro as a major, a diastereomer. Let us go for the less preferred conformation and look at the minor product also. So here this Me minus is coming from Me MgBr because the reaction is between alpha-phenyl propanaldehyde and MEMGBr. Alpha-phenyl propionaldehyde, the rear carbon that we are writing with S equal to hydrogen, M equal to Me, and L equal to pH, where S stands for smaller group, and M stands for medium-sized group, and L stands for a larger group. Let us go for the more preferred conformation. Less preferred conformation. This is more preferred because the interactions between non-bonded interaction between hydrogen and hydrogen. Let us go for the less preferred conformation now. Carbonyl group that is attached to hydrogen, and the large group will be in this side as represented in the model, and medium sized group will be here, and hydrogen, that is small sized group, will be here. This is smaller, this is larger, this is medium. Now you can see the interaction is between Me and hydrogen, so it is not preferred, less preferred. Interaction between methyl group and hydrogen. Now Me minus is attacking the carbonyl carbon, leading to the structure. Since it attacks, O minus goes there, so we have to write OH because the hydrogen will be abstracted after workup by the oxyanion that is formed by the attack of Me minus on carbonyl group, that is Grignard reagent. And we have Me here, and hydrogen as such we have to write, and pH, Me and hydrogen. It is more like an eclipse structure, so we have to write the stable structure, the staggered form of Newman projection. OH, Me, hydrogen, pH, and hydrogen. Me. Now this structure that we have to convert to Saha's projection. So Saha's staggered, now Saha's eclipsed. So this is equivalent to Threo structure minor. So this is a less preferred interaction that leads to a Threo product that will be minor in quantity. So that is what we can say. It is actually the stereochemistry that is being predicted in Cram's model. The same will be predicted here through Felkin Anh model, but the models are different, and it is one of the preferred model. That's all about Felkin Anh model.